Okay, we're gonna hope that everything's working here appropriately. I'm coming to you live from my home, so hopefully this is gonna work out pretty well. I'm gonna talk to you about section 3.3 and 3.4, which is all about solutions. So, not like the solution to a problem, but like liquid solutions, and it's gonna be super exciting. So there are hopefully this slide will switch places here. Great. So there are several terms that you need to know about, which is this or these terms are related to the idea of concentration, um, solute, solvent, dissolved, aqueous solutions, dilute, and concentrate. So if you look in section 3.3 of your text, what you will see is right in the beginning of solutions, it talks about the definition of these terms. I'm not going to go in and define all these terms. I trust you can kind of look in and see about all of them. Concentration is essentially the relative amount of a given solution component. And we'll talk more about how we calculate concentration. When we talk about solute, it's essentially what's being dissolved. So like the solute in my coffee here that I'm drinking, which is, I'm always drinking coffee apparently. The solute in this case would be like the cream or the sugar, and then the solvent is the coffee itself or the dissolving medium, if you want to think of it that way. Dissolved means what's being broken apart in our solution. So your textbooks, I think, refers to it as what is the component that's being dispersed. I don't use the term dispersed that often, but yeah, if you want to think of it that way, what's being broken apart or dispersed in the solution. So in this case, it'd be my sugar or my creamer. Aqueous solution just means that it's in water, where water is the solvent. So if we see something as aqueous, that means it's dissolved in water, where water is our solvent. Dilute means that there is more solvent to solute, meaning we have a low solute concentration, relatively low concentrations of our solute compared to our solvent. So you can think like a dilute coffee would not have a lot of sugar. A concentrated coffee would be super sweet because we would have a lot of sugar in it. So you can think about when things are made from concentrate, that means it's a very concentrated solution and then you dilute it with water. So that's kind of what that means. Next, we want to talk about this idea of how do we calculate concentration. So there's this idea of molarity. Now, molarity is an idea or a way for us to calculate concentration units. So concentration units are given to us as a big letter M. So I'm going to draw a big letter M here. And the big letter M stands for molarity. And the units for molarity are given to us in moles per liter. So you can remember what a mole is. It's a quantity of something. We're talking about like an amount of atoms. 1 mole is 6.022 times 10 to the 23rd. And then as we take that mole and we put it into solution, those units of atoms or molecules divided by the liters of solution is how we get to the unit we call molarity. So how do we use molarity in calculation? So I'm going to give you kind of a quick example here of how we calculate concentration. So a soft drink is 355 milliliters. If we have that amount of our soft drink, if we have that sample, it contains 0.133 moles. So that gives us the quantity of sucrose, which is sugar. So we've got an amount of sugar molecules. We want to know what is the molar concentration of sugar in our soft drink. So how do we approach this problem? It's pretty straightforward, right? We want to get where we're started with. We approach all these problems the same way. We want to go where we start with, which is 355 milliliters. So that is my starting volume of soft drink, right? I've got 355 milliliters. That's my beginning volume. And then I want to take that beginning volume and I need to get to something a little bit more useful. In this case, we're talking about moles per liter. So I need to get this in liters. So I'm going to take this amount and I'm going to multiply it. For 1 liter, every liter, I've got 1,000 milliliters, right? That's our conversion from 1 milliliter to a liter. So we're going to multiply this by the inverse of, so 1,000 milliliters over 1 liter. And I'm going to get rid of my milliliters because now I'm in units of liters, right? Which is good. So now I've got units of liters, and I'm going to put that amount underneath moles. So essentially you could say I've got however many 355 divided by 1,000. So I'm just going to do this here. We got 355 divided by 1,000, which should be 0.335. Yeah, 0.355. So that equals 0.355 liters, right? So that's going to be my amount in liters. Now I need to take and I've got to look at, okay, well, how many moles then do I have? And I know how many moles I have because it told me in the question, right? Let's go back and look at it, right? I've got 0.133 moles. So I'm going to take that amount of moles and I'm going to put that in my numerator and then I'm going to put underneath that my volume. So now I've got 0.133 moles per liter. And that's divided by 0.355, right? Because that's the volume of my soda, and that's how many moles I have in my soda. So now I can calculate the molarity, and if I do that, I get 0.375. And then the units of that, you could say moles per liter, or you could say big M, right? Big M for our molarity, right? That's what represents our molarity. So now what if you're given a question like, how do I get from, I know how to calculate molarity now, I know moles per liter, but how do I go and I calculate moles from that? So if given the molarity, how do I then determine how many moles of something I had? So let's say I'm drinking my soft drink, right? And let's say I take a sip of that soft drink, and I want to know, well, how much sugar did I just have, right? How many moles of sugar did I just take in? And the best way to do that is to say, okay, how much is a sip of soft drink? And let's say when I drink a sip of soft drink, the thing is like 10 milliliters. So let's say, okay, I'm going to take a 10 milliliter sip of a soft drink. All right, that's how much I drink real quick. And I want to know, okay, if I have 10 milliliters, how many moles of that did I just drink? How many moles of molecules of sugar did I have? So the way to do that then, so we take milliliters to kind of reverse the process here. I know that I've got 0.375 moles of this, in this can of soda, I've got 0.375 moles of sugar per liter, right? Now, the liters and milliliters are not going to cancel each other out. I can't do this right here because those liters and milliliters won't cancel each other out. But I can go ahead and add in here this other conversion factor to cancel milliliters and milliliters out, or milliliters and liters out. So I'm going to go and put that in. So I'm going to put in another conversion here because I know that 1,000 milliliters is 1 liter. So now I can cancel liters out, I can cancel milliliters out, and I'm left with units of moles. Okay, just like that. So now I know how much sugar is in 10 milliliters of soda. I want to sip, so I can kind of like, if I'm really watching my calories, I'm going to watch it down the molecular level. You could do that just by calculating it. So if I were to do this calculation, multiply everything out, I should get 0.004 moles of sugar, right? And if it's 0.0, let's see, 0.0400 would be correct to the amount of significant figures. If you were to calculate that out correctly. Well, actually, in this case, it's 10 milliliters. So, no, it should be one significant figure. So, there's one significant figure. Maybe I can write it on there. One significant figure. Because that's my 10 milliliters is one significant figure. And my final answer should also be one significant figure. Just so we're on the same page. So, that's kind of how you use molarity in calculations and how to determine the molarity of something given the amount. And I said I want to keep this video under 15 minutes. So right now I think we're sitting about 9 minutes. Next, what you want to do is talk about what are some other units for concentration. And if you want to kind of dig a little bit deeper in the molarity section, you can go look at example 3.18 in your text and it'll kind of help you dig in a little deeper there. So now we're going to go ahead and look at section 3.4, which is this idea of other units that we use to determine concentration. So another unit we use to calculate solution concentration is what we call mass percentage. Mass percentage is pretty straightforward. It is what it says. It's the percentage by mass in a solution. So mass percentage, so I'm just going to draw out the percentage there. Mass percentage is equal to the mass of one component divided by the mass of the entire solution. So mass, let's say mass of component X. So mass of X, oh, let's see, I messed up there. Mass of component X divided by the total mass of solution, right? So total mass of solution. Total mass of solution. And then that mass percentage is going to be multiplied by 100 because we're talking about a percentage, right? So that's how to calculate mass percentage, So if you want to look at an example of this, let's say if we had a 5 gram sample, this is example 3.22 from your text. If you had a 5 gram sample of spinal fluid, so let's say I've got a 5 gram sample of spinal fluid, and in that spinal fluid, it contains, so 5 gram sample, in that 5 gram sample of spinal fluid, it contains 0.00375 grams of sucrose. Or this is glucose, sorry, not sucrose. They like sugars, of glucose, right? So now I want to know, what is the mass percentage of glucose in this case? You probably look at this and be like, okay, take 0.00375, which is the component, which is glucose in the total sample, divided by the total by 5 grams. So 0.00375 divided by 5 should give me my mass percentage. So we're going to do that 0.00375 grams divided by 5 grams times 100. I apologize for the delay. It's got to go, signals are bouncing around, and so it's catching up. So when I do that, I should get 0.075%, right, as my glucose amount, okay? Or mass percentage of glucose. Volume percentage, same way as mass percentage. You just do it the other way around. You take the component of volume, the volume of the solute divided by the volume of solution, and you get the volume percentage. So I'm not really going to cover that one. It's very similar to mass percentage. Now you're just using volume. So you may see some, you probably heard of the term parts per million or parts per billion. And it's pretty, all you're doing is you're multiplying it times 10 to the 6th or times 10 to the 9th. So parts per million, so ppm, is equal to the mass of my solute, which we said is what is being dissolved, and then the dissolving medium, my mass of solution, or the total mass of solution, so solute and solvent, and we say times 10 to the 6, which is in parts per million, so that's parts per million. And then in parts per billion, it's times 10 to the 9th. So all of this is the same. It's just, that's an arrow, and it might look like a smiley face. All you're doing in this case is you are using the same thing, mass of solution, or mass of solute over mass of solution, and you take parts per billion, and that's just going to be times 10 to the 9th now, and that's parts per billion. So that's the only difference between parts per million and parts per billion. And that's your solution concentration. The units 3.3 and 3.4, how to calculate concentrations. If you want to run through some additional examples, we'll do that on Friday. But this should give you a pretty good foundation in regards to how to know the information that we need to do calculations in the practice problems we're going to be doing tomorrow. So, that's solutions. Hopefully you have found the solution to understanding solutions. So I'll see you on Friday. Thank you, everybody, for listening.